Alright, guys. So I'm going to do this first one. So what this says is it says if I have negative 6 x's and 4 y's, that would equal 20. And it also has y is actually equal to negative 7. So I'm going to use a stamp because I'm recording and I want everybody to be able to see it. Let's talk apples. There's an apple, right? Apple equals y. So how many apples do I have? I have 4 apples right here, right? I have 4 apples. But it tells me how much the apples are. How much is each apple? So don't I have, if I really wanted to, I could say 4 apples is the same as negative 28. Would you agree? Right? So when you read equations, you should actually read them. Not just write them, but read them. So as I read this now, I'm going to say to myself, so negative 6 x's, because that's what it is 6 x's with a negative sign in front of it, plus 4 y's, or 4 apples, right, equals 20. Well, how much are those apples worth? Negative 7. Negative 6x minus 28. Isn't that what I got over there? Minus 28 equals 20. So negative 6x equals, well, if I have negative 28, how much is it going to be over here? Positive 48. So if negative 6x's equals 48, then 1x must be equal to negative 7. Negative 8. I made the same exact mistake last period. Negative 8. So the point of intersection would be at negative 8, negative 7. So if there are 2 arrows being shot into the air with these paths, they would meet at negative 8, negative 7. You guys think you could do this one? Try that one. Solve for x on your whiteboards or on your desk. I'm going to walk around. So can you solve for x? Fun. All right. So you follow along with me, Joni, race. So I have a y here, 5 y's, like 5 apples. But it tells me that y equals 2x minus 4. So I say to myself, I have negative 6 x's plus 5 y's, but I know what y's are. They're 2x minus 4. And then equals 4. All right, so now I have all x's, so now I can solve. When you have an x and a y, you have 2 unknowns, so you can't solve. But if I only have 1 unknown, I can solve. This becomes negative 6x plus 10x minus 20 equals 4. Negative 6x and 10x makes 4x minus 20 equals 4. 4x equals 24, so x equals 6. What would I do finally?
Then you plug it back into the line.
Good job. So we're going to substitute it back. All right, so let's go back to our original equation, our original system. Thank you, Florencia, for your attention. Okay, so I want to find at what height is Friar Tuck's apple when Robin's arrow pierces it. All right, so let's figure out what the apple's doing first. This one's the apple, right? So let's graph the apple. Can you guys make sense of that equation right there? It's a parabola, right?
Oh,
What's
yeah.
its vertex? Lucas, what's its vertex? No, positive 2, 9. Good. So I'm going to go over 2 and up 9. Is it pointing up or is it pointing down, Tristan? It's pointing down, right? What's the, because of the negative, so it looks like this. What's the LLR? LLR is 1 or negative 1, whichever way you want to look at it. And so what's P? 1/4 or 0.25. Good. You guys are rock stars. All right. So I'm going to use a different color because that's super close on a graph. So this isn't going to be a very accurate graph, right? Wait 1 second. It's not going to be a very accurate graph, right? Because I'm going to go down 1/4 and up 1/4 and out 1/2 and out 1/2 to make a whole. That's not a very accurate graph. But we're going to go with it. Now let's do Robin's arrow. So Robin's arrow is y equals 2x plus 5. This one's a lot easier. 1, 2, 3, 4, 5. Up 2 over 1, up 2, bingo. We got it. I'm going to stop there because this will be the negative direction. He's not shooting in the negative direction, right? We're talking about, in reality, we're talking about just this part of the graph because Robin and Friar Tuck are not working in the negatives, right? They're positive people. They're in the positive realm of the world, right? Does that make sense? Why we don't even need our arrow to go any further than this? All right. So since I have this type of graph that you can't really see what's going on, we should probably do it algebraically just to make sure, right? Make sense? So what we're going to do is we're going to use substitution today rather than elimination. But on your homework tonight, you could use either one. You could use substitution or elimination, whichever one makes more sense. So in this one, actually, substitution makes a lot more sense, right? Unless you were to subtract, actually, I would disagree with that one. I could distribute that, and then I could actually eliminate right there, right? Well, let's do substitution just because that's what our lesson is today. All right, so I'm going to substitute in 2x plus 5 wherever I see a y. So I'm going to do that right now. So I'm going to rewrite this, negative 2x plus 5. That's what we substituted in. Lucas, you should be looking forward. Minus 9. I like our new seats, by the way. Equals x minus 2 squared. Let's go ahead and FOIL that. But I'm going to show you, this is a perfect square binomial, right? So it's got those properties to it that we use to actually make when we completed the square. So isn't that x squared? And isn't that 2 squared, which is 4? So now and this is going to be negative something. Well, let's see. X minus 2, x minus 2, x times x is x squared. I've got that. Negative 2 times negative 2 is positive 4. And negative 2x and negative 2x is going to give me negative 4x. So I could just send 2x and 2x makes 4x, right? It's going to be negative because negative 2x and negative 2x makes negative 4x. All right, moving on. So let's finish this up. I better combine my terms in here. So negative 2x minus 4 equals x squared minus 4x plus 4. Negative 2x plus 4 equals x squared minus 4x plus 4. Now what could we do? Start moving stuff over here. Lucas, I need you looking up here. I want you to look up here. So if I move the 2x over and I move the 4 over, I'm going to have nothing over here. X squared, he's the only one. Negative 4x, if I add 2x to this side, that's going to be negative 2x. And if I subtract 4 from both sides, oh, that becomes 0 as well. What am I going to do with that? You could factor it. Some of you like to do that. Or you could complete the square. Or you could use quadratic formula. Or you could do the easiest thing, which is what Sreya said, factor out an x. So what does x equal? 0 and 2. So x equals 0 and x equals 2. Okay, does that match our graph so far? Do we have an x at 0 and an x at 2? We do. Now we just have to find our y's. So in order to find our y's, which one of these would you like to use? The top one or the bottom one? I'd rather use the bottom one too. So if I use the bottom one, let's use green this time. So using these two right here, I'm going to say y equals 2x's plus 5, y equals 2x's plus 5. I'm going to put these two values in, which is 0 and 2. So y, I did it again. Y equals 0 plus 5, which is 5, and y equals 4 plus 5, which is 9. So this one solution is 0, 5, and this solution is 2, 9. Now this is the only part of word problems that you really have to do some work on. I have two solutions. Is this my answer? It's not. Why? One of them's wrong. Why? It's asking for the intersection, but couldn't I really keep going with my parabola and it must cross there? There's two intersections. But in what? The one that's the answer is the one that's the vertex. Why? Where it's asking where they meet, right? It's asking where does the apple, once you throw it up in the air, where does the arrow hit the apple? That's there. That's where the arrow hits the apple, right there. Where they started. That's where he started shooting the arrow and started throwing the apple. But actually, in reality, it's more complex than that. And I'm just gonna hit it really, really quick. Check this out. I'm not even gonna do that. I'm gonna do this. So here is Robin Hood shooting the arrow, right? Here is how high it goes, right? And here is Friar Tuck throwing the apple in the air. It's actually three-dimensional. I'm going to show you, I'm going to pause the video, but I'm going to show you in real life, okay? So I'm going to do the hardest problem, and then you guys are going to start doing the homework. Oh, I already did it. Let me erase it. This is the hardest one. You guys ready? I really need you to stick with me because this stuff is pretty dry and long. Okay. You want to see if you can do it? If you want to try and do it, go ahead. All right. So if I want to substitute, do you guys see where I could substitute? So I see that 16x, negative 16x, is equal to y squared. So that means I could substitute negative 16x anywhere I see a y squared. So I'm going to rewrite that. So I have x plus 4 squared over 4 plus, instead of y squared, I'm going to write negative 16x over 64 equals 1. Do you guys see what I could do next? It looks like an ellipse, but it's not because we don't have a y, right? And it's not squared. Let me see anything else I could do up there before I decide to clear.
Oh, you can,
Christina, could you switch with Lucas, please? He's having a hard time looking forward. I could expand it. There's something I could do before I expand it. Okay, so normally I would say I want to get rid of the fraction. So I could multiply everybody by 64 and get rid of the fraction, but there's something else I could do before that to make my life a lot easier. You could reduce. Aren't there 4 16s in 64? Because 16 times 4 is 64. So I could cancel that and make this a 4. That makes my life a little bit easier, right? So I'm going to rewrite it. That way I just don't make any mistakes. So I have x plus 4 squared over 4 plus negative x over 4 equals 1. Now what can we do? I could combine them right now. I could, because they have matching. But what if they didn't have matching? What would we do right now? We would get rid of the fraction. How could we get rid of the fraction? Multiply everybody by 4. Good. So we're going to multiply that by 4, that by 4, and that by 4. Do you see how that's a better option, Sarah? Good. But you could have done what you said and then got rid of the 4s. Okay, so this is going to go away. This is going to go away. And I'm left with x plus 4 squared minus x equals 4. Now what? Expand x plus 4. I'm going to do it the algebra 2 way. That's going to be squared. That's going to be squared. And what's the middle term going to be? 4x and 4x makes x, going to be positive, minus x equals 4. Yikes. All right, so now I have x squared, so I don't have any other x squared. I have 8x minus x, which is 7x. And if I take the 4 off that side, it's going to be plus 12 equals 0. Now, what different options do I have now? What? I could factor it. What if I didn't see that I could factor it? What if the 12 was over here? What would you guys try to do? Complete the square, but why wouldn't I complete the square with that one? Because that's not an even number. Some of you could even use quadratic formula, but why would you want to make your life hard? It's too much work when I could just factor it, because I know that that's 3 and 4, and 3x's and 4x's make 7x's. So x either equals negative 3 or x equals negative 4. Phew, that was a lot of work. Are we done?
No.
No! What did I say I was going to do with these before I even started? I said I was going to graph them. Right? Let me graph this one. But I'm going to leave this. All right. So if I'm going to graph the easier one first. What shape is this, folks? An ellipse. Lucas, you're still looking forward and you're still talking. Can you come sit up here, please? That'd be perfect. That would be fantastic. Okay. So my 0 on my x's here is -4 and 0. So I'm at -1, 2, 3, 4, and 0. How far out am I going on my x-axis? Lucas, how far out am I going on my x-axis? Unknown. Shocking. Out 2 and out 2. Because 2 squared. And how far are we going out on this one? Which is 8 squared. Do you guys see that? Philip, you know that you have to go out 8, but for some reason, students get really, really tripped up by that. I don't know why. It's the same thing, right? But isn't it the same thing? Okay, so we're going to go up 8 and down 8. So there is my ellipse. It is kind of nice, isn't it? Okay, here's my parabola. My parabola has a center of, or a vertex of, what's the vertex on this? Is there anything with x? No. Is there anything with y? No. 0, 0. Which way is my ellipse pointing? Up and down or right and left? Left and right. Is it pointing left or is it pointing right? Because it's negative, it's pointing left. What's the LLR? 16. So what's P? So we're going to go over 4. 1, 2, 3, 4. And over 4, 1, 2, 3, 4. You guys said it's pointing left. So there's my directrix. There's my focus. How far out am I going to go on my focus? That's not that hard. Okay, so here is what I originally got. Because I drew my picture first, and then I did the math, and then I stopped doing the math because I got lazy. And I said, oh yeah, -4, 8, and -4, -8. -4, 8, and -4, -8. That makes complete sense, right? I missed something. Because I was being lazy, I missed the fact that there's another point here. -1, 2, 3. After I do the algebra with you in just a minute, you're going to see that when I go back -3 on the x-axis, I go up radical 48. How much is radical 48 is almost a perfect square. What would be the next perfect square? 7. Radical 49. So 1, 2, 3, 4, 5, 6. Oh, look at that. They'd cross there. They cross there, and it crosses 1, 2, 3, 4, 5, 6. Look, it crosses there too. But we would have missed it by just graphing. Right? You would have said, oh, look, intersection here, intersection here. Done deal. We're done. Right? But there's actually 4 intersections. So let's look back at the math. It always happens in this class, like at this time, huh? Okay. So let's go back to the math. Didn't I come up with 2 different x values? So when I plug in -4, I'm going to get +8 and -8. And when I plug in -3, I'm going to get √48 positive and √48 negative. So I'm just going to do that really, really quick. Which one would you use? Well, no. Which one of these would you use? The top one. -16x equals y squared. So -16x equals y squared. And -16x equals y squared. I'm going to put soon as it lets me. You guys are being very good. This is a lot, right? -4, -3. Let's see what happens. When I put -4 in, I get positive 64. 64 equals y squared. That's easy, right? Y equals plus and minus 8. Because when you put the square root, you're going to get plus 8 and minus 8. This one, I'm going to get positive 48 equals y squared. And when I take the square root of both sides, I get y equals plus or minus almost 7. That's what that means. That's what you should be telling yourself. Not square root of 48, but almost 7. Make sense? Okay, so that's the hardest one on your homework. So now what we're going to do, and that's on the back side. I want you to do the front side. We're going to do one. This is the hardest one. It's just a lot, right? So you guys have a group quiz tomorrow. Yes, you do. I'm going to actually give you your homework right now, and you are going to copy this one down as quickly as possible. And then I can try and raise this part up. There we go. Now you can kind of see all of it? Almost all of it? All right. So I'm going to pause this. I'm going to let you guys copy this one down. Then you're going to do number 1, and then I'm going to show you number 1's answer, and we're going to do the work. Then we're going to do number 2, right? I'm hoping we're going to get through the front side, and then you guys can do the back side for homework. That should be good.